hybrid electric vehicle we have seen, and so today we will go with motion and dynamics for hybrid and electric vehicle. Also, we can call it as like conventional vehicle. Also, if you consider any kind of vehicle, so dynamic is a plays a very important role. So in the case of vehicle performance, so we should know which are the forces are acting on the vehicle. Okay, that is not basically for the electric and hybrid only. So that is common if you consider any kind of forces which are acting on the vehicle, and how they are affecting the uh, performance of the vehicle. It is very important to know which are the forces are acting on the vehicle. So before that, so motion and dynamic equation for vehicle. So dynamic equations like uh, you have to understand that how you are going to find out the reaction forces which are acting on the vehicle. So by writing the equation of motion. So equation of motions we will write at the end of this chapter. So we are going to take the vehicle is moving in uphill. So when it is moving in uphill, so today we will see which are the forces are acting on whenever it moves in the uphill. Okay, so and we will see some of the terms are there, how the performance of the vehicle, what whenever we consider a normal internal combustion engine or any kind of vehicle, so how it affects the performance of the vehicle. If you consider like electric vehicle, also same kind of parameters we are going to see, and if you consider hybrid electric vehicle, also same. So the fundamental vehicle design involves basic principle like of physics, such as like especially we are going to consider the Newton's like to study the dynamic and electric of dynamics of electric and hybrid vehicle. So especially the Newton's second law of motion. According to what Newton's second law of motion, the acceleration of an object is proportional. Okay, what it is proportional? It is proportional to force exerted on it. Okay, so whenever the object accelerates, the net force acting on it is a zero. So we will understand later on. So bit of introduction I'm giving regarding the dynamic of HEV. Okay, and so which is force acting on it is zero. Okay, several forces are acting uh, on the vehicle. Okay, and the net or resultant force governs the motion according to the Newton second law. Okay, so we can write down the equations with the help of WF. We call it as a reaction force which is acting on the front of the tire, and a reaction force which is acting on the rear of the tire. Okay, uh, okay, the force of propulsion unit, okay, whatever the propulsional unit is there, so that will helps the vehicle to overcome all the resisting forces due to gravity, as well as such as gravity, air, and tire resistance, as well as the acceleration of the vehicle, which depends on different parameters such as the different road conditions. Whenever we consider the tire of the vehicle, so road condition is important. So aerodynamic of the vehicle is very important. How you are going to design your vehicle, so which reduces the drag. So air resistance we call it as. Okay, and the power delivered by the unit, whether it is a motor or whether it is like hybrid electric vehicle or whether it is normal conventional unit. Okay, as well as vehicle resistance, some of the parameter which will be affect the acceleration of the vehicle, and dynamic equations can be written by using this whenever the vehicle is moving uphill, or whenever the vehicle is moving on a flat road. So there are different dynamic equations are there. Okay, so we will not going to see now. We are going to derive an equations for WF and WR at the end at the completion of this chapter. Whenever we are going to complete, we are going to derive WF and WR. How we are going to derive the WF and which are the forces which are acting on the vehicle. Considering all those things, we are going to derive that equation. Okay, so these are the general description of vehicle movement. Okay, whenever we uh, take the general description, the vehicle motion can be completely determined by which analyzing the forces. All the forces acting on it we have to analyze. Depends on the direction of motion, in which direction the vehicle is moving. According to that, we are going to take. So here you can see in this figure, so rolling resistance is one of the important parameter. Aerodynamic drag when it is uphill resistance, whenever it is moving in the uh, upward direction, it is makes a very important role. Okay, the forces acting on the vehicle which is moving up. Okay, one is a FT. So over here you can see the forces are acting over here, TRF and TRR. So these are called as a rolling resistance. The first force which is acting on the vehicle is like we can say it as a FW. So FW is called as a aerodynamic force which is acting on the vehicle when the vehicle is accelerating in the upward direction. Okay, so एक एक्सेलरेट हो रहा है तो व्हीकल ट्राई कर रहा है मूव करने के लिए अपवर्ड डायरेक्शन में, लेकिन ड्रैग फोर्स क्या कर रहा है, एरोडायनेमिक ड्रैग फोर्स विच इज pushing the vehicle in the downward direction. So what happens when it is pushing in the downward, we write it as a equation called rho a b d square, I guess that is the equation for aerodynamic force. The aerodynamic force can be written as RA also. Here it has been indicated with the help of FW. Okay, FW, it has been indicated. Okay, so the another force is a tractive force. So tractive force is acting in this direction opposite, in the opposite. Sorry, whichever direction the vehicle is moving, in that direction the tractive force is acting. So it depends. So where the what is the type of vehicle, whether it is a front wheel drive, whether it is a rear wheel drive, or whether it is a all wheel drive. Okay, depends. Okay, the tractive force which will be generated on the vehicle. So if it is all wheel drive, we can consider it on the both the tire. Okay, so in general also we will consider whenever we are writing the equations and all, so we will consider the tractive force for the front tire as well as for the rear tire. So the tractive force in contact area between the tires of the driven wheel and the road surface, which will propel the vehicle in the forward direction. As I said, it propels the vehicle in forward direction, as well as tractive force produced by the power plant and transferred to the driving wheel via transmission to the final drive as well. And when the vehicle moves, it encounters a which force? Resistive force. It encounters what? Resistive force, and force that tries to retards its motion. Okay, motion कम करने के लिए try करता है. The resistive force are, these are the resistive forces. Okay, मतलब motion को resist करने के लिए rolling resistance, this is a major thing in the vehicle. Aerodynamic drag as well as uphill resistance. These are the three resistive forces are there, so that this resistive force opposes the motion of the vehicle. Now we can understand which are the forces are acting on the vehicle. I have already told you that this is an aerodynamic force, and so this is the aerodynamic force height. Okay, where it is acting we can consider. Usually we'll take the reference of CG. Okay, CG is located over here. Okay, if it is flat road, the CG is what we call it. CG is acting in downward direction because center of acceleration, center of gravity is over here. So this HA, so we call it as HW or HA. Okay, HA is equal to HG. Okay, HG is a height of the uh, ground level to the center of the gravity. HG, HA, HW, and one more force force is acting over here in the backward direction. Okay, so when we connect a vehicle with the help of trailer, so draw bar pull we call it as draw bar pull. So if I connect a trailer to this, the one more force is acting in the downward direction, that is a draw bar pull. Okay, we call it as a FD. यहाँ पे एक ट्रेलर लगा दिया और एक फोर्स एक्ट करेगा इधर, तो वो उसका हाइट रहेगा HD. So we can consider height of this aerodynamic height of vehicle from ground to CG, HG. So and HD, we can consider all the heights are equal. Okay, so these are the forces which are acting. Okay, so here this force is acting in opposite direction. So usually we write F is equal to ma. So this is the force over here, it is acting, F is equal to ma is acting in the opposite direction. Okay, mass into acceleration. So that can be written as a dl numbers force also. Okay, usually we not written as a pseudo force, but also it can be written as a dl numbers force whenever we are deriving the equations. Okay, whenever we are deriving the equation, we can consider it as m divided by into a shayad say we write it like that, m divided by g into a v, right. So we will see later on that whenever we derive the equation for reaction force of front wheel and reaction force for rear wheel. So over here the force is acting at the CG, which because it creates an angle alpha, so that over here the forces are resolved into two. So one force is resolved in a horizontal direction, one more force is resolved in the uh, vertical direction. So over here the theta s angle will be generated over here. Okay, theta s angle will be generated. So and vertically the load is acting. Okay, that is normal load is acting in the vertical direction. Okay, so how we are going to if you wanted to derive the equations, okay, for any vehicle, you need the dimensions. If you wanted to take the equation of motion along the a direction, along this, you suppose this is an a and this is an b. If you wanted to take the moment about a, and if you wanted to take the moment about b, you required a vehicle dimensions. Without dimensions we cannot write down other equation of motion. Okay, we cannot find out the reaction forces. Okay, that is very important. Okay, so over here you can see these are the forces which are acting on the vehicle. So from the front tire center point to the CG, we can consider it as LA or L1. We can, depends on you how you are going to give the nomenclatures. And from the center of the gravity to the second to the rear tire, we can consider it as a L2. Okay, L2 or LB. So total length from over here to over here we can consider it as a L. Okay, there are two resistance which has been indicated over here. Okay, which is acting in the opposite direction. Okay, so which are the forces which are acting in the opposite direction? TRF and TRR. What are those things? Can anybody? Can anybody let
Sir, it's traction, sir. Traction.
Tractive
traction?
force, tractive force at front wheel and tractive force at rear wheel.
What is this?
Tractive force,
This is tractive force. Okay, that is correct. What is this? Opposite force कौन सा act होता है? Oppositely कौन सा होता है act? Which force is acting opposite?
rolling,
This is acting opposite TRF.
rolling resistance,
Yes, it is correct. Over here only I have indicated that rolling resistance. Okay, rolling resistance at the front tire, rolling resistance at the rear tire. So it is one of the important term that many of the students think that a rolling resistance is a frictional resistance. Can anybody tell me? Yes,
Yes.
yes, it is frictional resistance.
Yes, sir.
No, it is not. Many of we are thinking that it is a frictional resistance, but it is not a frictional resistance. When we are considering a rolling resistance, okay, so this is called uh, as I have written the equations for using Newton's law of second law of motion using acceleration expressed as summation of ft minus summation of resistat divided by delta m. Okay, so this is the total resistance. Okay, just I have written this. The vehicle acceleration can be expressed like this. So v is a vehicle speed, and ft is a total tractive effort. Okay, f resistance is a total resistance, m is a total mass of the vehicle, and delta is a mass factor of converting into rotational inertia of the rotating component. Okay, leave it over. Just I have written the equation. So coming to the rolling resistance. Okay, rolling resistance is one of the most important parameter. So when we consider a vehicle performance, okay, rolling resistance is not a what I said frictional resistance. It is not a frictional resistance. Whenever we are going to consider a tire, okay, the tire is made up of like rubber. Okay, rubber, or we can in any other material, rubber, material of tire. So we will consider here the combination of two. Okay, if it is the elasticity, so we will consider it as a spring. Okay, and dashpot. Okay, with the help of that, we are going to see the deformation of the contact patch between the road surface and the tire. Okay, so contact patch is one, that is the main important thing. How the pressure, inflation pressure is acting on the tire, that will be seen. Okay, over here I guess the elastomer can be used to uh, manufacture a tire. Okay, that is the material which will be effect on the vehicle performance. So vehicle performance मतलब किस पे effect करेगा, effect karega engine or whatever the drivetrain is there, that most of the at around 25 to 30% of the vehicle performance will be effect on the uh, what we call it as engine or drivetrain of the vehicle. So so many of the people, many of the vehicle manufacturer should try to reduce the rolling resistance, because it is very difficult to reduce the rolling resistance. It will come whenever our tire goes on the road. Rolling resistance will opposes the motion of vehicle. मतलब tractive force पीछे से act कर रहा है तो rolling resistance सामने से act करेगा. The rolling resistance of tire on hard surface, okay, hard surface uh, is due to hysteresis in the tire material. So what is that hysteresis material? You can see this figure. We can indicate with the help of stress strain curve also. Okay, uh, whenever the tire is loading, the condition is different, and whenever the tire is unloading, the condition is different. Okay, so when you take an elastic material, okay, so when I'm going to load, so it goes into a one path. When I am going to unload, that elastic material, that follows the same path. But in the case of tire, it follows the different path. You can see this figure over here. Okay, so over here the force is acting on the tire, so that it deflects the, it deformation will takes place over here between, मतलब प्रेस हो जाएगा, डिफॉर्म हो जाएगा टायर यहाँ पे. तो यहाँ पे एक्ट करेगा आपका कॉन्टैक्ट प्रेशर, मतलब प्रेशर एक्ट करेगा, प्रेशर डिस्ट्रीब्यूट होगा पूरा। तो व्हेन दिस रीजन इज कॉल्ड एज अ लोडिंग रीजन, लोडिंग रीजन, ओके, द लोडिंग रीजन, the pressure in the contact area between the tire and the ground is distributed symmetrically over here, okay, यहाँ पे टायर और कॉन्टैक्ट एरिया के बीच में प्रेशर डिस्ट्रीब्यूट होगा, सिमेट्रिक होगा, ओके। एंड द सेंटर लाइन ऑफ द फोर्स, मतलब रिजल्टेंट फोर्स कौन सा एक्ट हो रहा है इधर, सेंटर लाइन ऑफ द रिजल्टिंग रिएक्शन फोर्स इज एक्टिंग पीजेड, ओके, पीजेड इज अलाइंड विद द पी, ओके, यहाँ किससे अलाइन हो रहा है, P, and the deformation is like we are call it as a Z, okay, the deformation we call it as a Z versus the load P, okay, so versus the load we are taking it as a P in the loading and unloading process. This is a loading process and this is an unloading process, okay, loading and unloading process as shown in this figure, okay। so ये वाला contact pressure जो है ये loading है, okay, then where we are going to consider the unloading part, yes, unloading कहाँ पे दिख रहा है आप लोगों को, so this is called as a loading। यहाँ पे जब भी टायर रोल होगा in this direction, so in the forward direction or in this direction when the tire is loading, so wherever the deformation takes place that is called as a loading part, and so here you can see, so this is an unloading part, मतलब यहाँ पे रोल होता है टायर, रोल होने के बाद क्या होता है, ये जो पोर्शन है अनलोड होता है, फिर नेक्स्ट पोर्शन जो ये भी अनलोडिंग कंडीशन में ही होगा सामने का, जब भी ये रोल होगा टायर, सो ये वाला पोर्शन पीछे का पोर्शन लोड हो जाएगा, ये वाला पोर्शन अनलोड हो जाएगा, ओके, सो लोड हो जाएगा फिर पीछे आ जाएगा तो अनलोड हो जाएगा, फिर लोड होगा आगे का पोर्शन फिर अनलोड हो जाएगा, लोडिंग एंड अनलोडिंग। हियर यू कैन सी this figure, okay, whatever we have seen due to the hysteresis force, okay, that is P, for the same deformation Z of the tire material loading is greater than that of than during the unloading, hence the hysteresis causes an asymmetric distribution of the ground reaction forces, okay, you can see this is a force P1 and this is a P2, so this path it takes while loading and this path this takes while unloading, so you can see the load during unloading and this is a load during the loading, okay। Suppose when the tire is area, how we are going to find out the area, or area is written, okay, so whenever it rolls, okay, so it is uniformly distributed, but whenever it rolls, okay, so what happens, the deformation of the tire took place over here, it is indicated with the help of A over here, deformation of the tire. So it is when the tire rolls, the leading half of the contact area is the loading and trailing half is unloading. So here the pressure on the leading half side is greater than the pressure on the trailing half is as lesser, okay, so this result in ground reaction force shifting forward, okay, whenever the ground reaction force shifts, it creates a movement that opposes the rolling of the wheel. This is how it opposes the rolling out on soft surface, as well as we are going to take on the hard surface also. So both the things we are going to consider over here. In the rolling resistance, the mainly caused by the deformation by ground surfaces only. In this case, the ground reaction force almost completely shift to the backward side, okay, leading half we can call it as. So that can be written as TR, okay, TR is a rolling resistance. Rolling resistance is nothing but, so P into A is called as a deformation. So over here, it can be shown over here, the deformation of the tire, and P is a normal load acting on the center of the rolling wheel. So P into A, we can write it like that. P can be written as W, or P we can write. Load can be written as like anything, any kind of parameter can be indicated with the help of load. Okay. So P can be replaced with the mg into A, where TR is a rolling resistance, P is a normal load acting on the center of rolling wheel, and M is the mass of the vehicle, G is acceleration due to gravity, and A is a deformation of the tire, so which can be indicated over here. So मतलब ये ये जो लाइन दिख रहा है, ये सिमेट्रिकल कॉन्टैक्ट पैच जो दिख रहा है, सो सिमेट्रिकल दिख रहा है. ओके, ये वाला जो थोड़ा सा whenever it unloads and loads the vehicle, so that the deformations will be created over here or in this place. Okay. So also over here in this also you can see this is whenever unloading. So this is the contact patch we can see over here. Okay, to keep the rolling, the force FR acting on the center of wheel required to balance the rolling resistance movement. It is used to balance the rolling resistance movement. Okay, so that can be indicated over here with the help of PZ. Okay, and the rolling resistance movement is expressed over here. So R dyne, we can dynamic radius of the tire. So we can consider it as this is the dynamic radius of the tire, and TR is nothing but rolling resistance. So TR can be replaced with the PA. So A divided by R dyne, which can be replaced with the FR. Okay, so rolling resistance TR, how I can write rolling resistance is equal to, how I can write the rolling resistance? So here rolling resistance and magnitude is given by F into PR. Rolling resistance moment can be equivalent to replaced by horizontal force acting on where the center of the direction is opposite to the moment of wheel. Okay, that is equivalent force called rolling resistance and magnitude. Okay, which is given by F is equal to P into FR. Okay, so this is the normal load as usual, and FR is a rolling resistance coefficient. Rolling resistance can be written as TR is equal to rolling resistance coefficient into load. Also we can write it like that also, normal acting load as well as the rolling resistance coefficient. So the previous equation can be rewritten as so like this: PR cos alpha. Okay, that is P is replaced with the help of mg, and FR is rolling resistance coefficient. Alpha is a road angle. Okay, road angle in radians. Okay, which when it vehicle is moving up a gradient, मतलब vehicle moving up हो रहा है तो वो टाइम पे angle create हो जाता है ना, that normal force P is replaced by the component that is perpendicular to the road surface, which is rewritten the equation like this. मतलब ऐसा equation हम लोग write कर सकते हैं. So rolling resistance coefficient is a function of what? Can anybody tell me? Rolling resistance coefficient is function of what? Just the rolling resistance because of performance, it depends on the performance of the vehicle. So that's why I'm going through the rolling resistance, okay, of conventional vehicle or hybrid electric vehicle. You can anything you can say, any vehicle you can take, this plays an important role, the rolling resistance. Which are the functions of resistance coefficient? You can see the rolling resistance coefficient FR is a function of tire material, okay, tire structure, tire temperature, tire inflation pressure. So when we see this tire inflation pressure, so contact patches comes into picture. Okay, then thread geometry, skeleton जैसा रहता है thread geometry. So there is a whole chapter is on the tires. In that more and more you can study on the rolling resistance. उसके material से लेके last तक मतलब पूरा उसका हिस्ट्री एक पूरा एक बुक है उसका। ओके, तो थ्रेड ज्योमेट्री कैसा रहना चाहिए, there are different types of tires, according to that there are different types of thread geometries are there. Okay, according to that it acts. Okay, road roughness depends on the road also, it affects the vehicle performance also. Also rolling resistance also, it helps in the case of braking also, it helps braking. So whenever we brake, so also the wheels, the rolling resistance, whatever the direction of force is acting opposite to the tractive force, in that particular direction only brake force is active. Whenever we brake the vehicle, the rolling resistance is very plays a very important role. Okay, so that is the main thing. And road roughness is also very one of the major thing when we consider the coefficient. Okay, rolling resistance coefficient. So presence or of absence of liquid on the road. Whenever the different environmental conditions, okay, so that also the function of rolling resistance coefficient. So you can see this table, typically values of rolling resistance coefficient. So why I'm putting so much of uh, stress on so much of importance on the rolling resistance, because it plays a very vital role in the case of vehicle performance. Okay, so most of the people are working in the field of rolling resistance, that they didn't that has to be accepted. Okay, if the vehicle is giving a less performance because of rolling resistance. Okay, so this table shows you the conditions, which are the conditions, and what is the value of rolling resistance coefficient. Okay, if you can see car tire on a smooth tarmac road, so that is the point 0.01, the rolling resistance will be there. So car is on a concrete road, the point 0.011, these are the standard value is taken from the technical papers. Okay, and car tire on the rolled gravel road, that is the value is point 0.02, and tar is a tar road on the tar road, so 0.025. Okay, and unpaved road 0.05, and bad earth tracks, that is 0.16, loose sand maybe 0.15 to 0.3 का rolling resistance रहेगा. And truck tire on the concrete or asphalt road, that is the rolling resistance is 0.006 to 0.01. Wheel on iron rail is 0.001 to 0.02. So if you study any kind of vehicle, you should aware of this particular term called as a rolling resistance. Okay, so second term is like aerodynamic drag. So this is also one of the most important thing. So usually the derivation should be done on our this whatever I have uh, given a equation over here. I have given you the direct equation, but you don't have any derivation for this. Just I'll show you the reaction forces which are acting on the vehicle by next lecture or next to next lecture. So we will derive that equation definitely, because you should know how we are going to derive the equation for derive the equation uh, for WF and WR at the front wheel and as well as the rear wheel. Okay, here this is also one of the important thing in the vehicle performance, aerodynamic drag. So whenever the vehicle is moving, so there are many tests are available to test the aerodynamic drag. So many of the people are working to reduce the drag coefficient of the vehicle. Okay, drag coefficient ज्यादा नहीं रहना चाहिए, drag coefficient बहुत ही कम रहना चाहिए, so that the shape of the vehicle is skin and shape of the vehicle is very takes an important role over here. Okay, so a vehicle traveling at a particular speed uh, in air encounters a force resisting its motion. मतलब इससे क्या हो जाएगा, आपका aerodynamic drag से भी आपका vehicle performance, मतलब in the case of IC engine only you can see if aerodynamics it is resisting the motion of vehicle. If you consider like hybrid electric vehicle, that is acting on two propulsion unit. Okay, either the motor or either the internal combustion engine. You can see the size of the internal combustion will be very lesser in the case of a hybrid electric vehicle, because it is a combination of two power. So you can see in the electric vehicle also, so these plays a major role. So by looking out these parameters, how we are going to improve the performance of your electric vehicle or hybrid electric vehicle. So we are looking out that particular thing. So in that, the this force is known as a aerodynamic drag. Okay, so aerodynamic drag. So we can indicate the uh, drag coefficient by CD. Okay, CD, it has been given over here, or aerodynamic drag coefficient we call it as. Okay, so here we have a two, shape drag and skin effect. Okay, the shape drag is due to the shape of the vehicle. As name indicates, the shape drag is due to the shape of the vehicle. Uh, the forward motion of the vehicle pushes the air in the front. Okay, जब भी vehicle movement होते रहता है तो it pushes in the backward direction, so air cannot instantaneously move out of the way, and it pressure in it is does increase. Whatever the pressure is there on the vehicle, that will be increase. Okay, so this what it results in, it results in high pressure in front of the vehicle. Okay, and the air behind the vehicle cannot be instantaneously fill this space left by the forward motion of the vehicle. Okay, so this creates a zone of what, low pressure. Low pressure create karta hai. Okay, and motion of the vehicle creates two zone pressure. Okay, one is in the forward direction, one is in the backward direction. Okay, high pressure zone is in front of vehicle, opposes its movement. Okay, and other hand, the pressure zone developed by the rear of the vehicle that opposites motion by pulling it backwards. Okay, एक क्वेश्चन, एक pressure forward direction, एक क्वेश्चन backward direction. The more pressure is acting in the front, and more pressure, less pressure is acting in the backward direction. Okay, so that is how the shape drag is there. In the case of shape drag, मतलब आधा आगे फ्रंट साइड में ज्यादा रहता है प्रेशर और रियर साइड में थोड़ा सा कम रहता है. तो रियर साइड वाला एयर ड्रैग जो है वो पुल करने के पीछे के साइड में धकेलने के लिए ट्राई करता है, फ्रंट वाला पुश करता है बैकवर्ड साइड में. दोनों वही काम करते हैं. इसकी वजह से क्या होता है, इसकी वजह से इट इफेक्ट्स the performance again. It takes the load on the vehicle. Okay, that's why many of the people are working in the aerodynamic shape of the vehicle. So आपने एरोप्लेन वगैरह देखा होगा, शेप कैसे रहता है, एकदम स्मूथली. मतलब एयर अगर भी जाएगा तो ड्रैग कोएफिशिएंट बहुत ही कम रहता है अगर एरोप्लेन का आप देखोगे तो. And skin of the vehicle moves almost at the speed of vehicle, while the air मतलब जब भी मूव करते रहता है. सो स्किन इज नथिंग बट द बॉडी ऑफ द व्हीकल. व्हेनेवर इट इज मूविंग इन द फॉरवर्ड डायरेक्शन, it moves along with the air. It bisects the air and it goes along with the air, and from vehicle remains still. Okay, there are two layers, air layer moving at the vehicle speed, and that is called as a static layer. Okay, static layer we call it as over here. Okay, the difference in the speed between two air molecules produces a friction. Okay, and the friction results in the second component of aerodynamic drag is known as a skin effect. मतलब जब भी जाते रहते हैं हम लोग, the air along with the air, the vehicle is moving, the body of the vehicle is moving. Okay, so in that speed between two air molecules produces a friction. So it produces an friction. That friction results in the second component, that is an aerodynamic drag. Okay, and this drag is known as the skin effect. Okay, we call it as a skin effect. Generally, aerodynamic drag is expressed by using this equation. So as I said, Fw. So Fw, you can see this is acting in the opposite direction. Okay, when a vehicle is moving in this direction, so this can be written as 1/2. So this also can this thing can be derived, and we will get this formula, that is half rho AF CD V square. Okay, so this is a directly derived formula. okay, for aerodynamic drag. So where rho is called as the density of air in kg per cubic meter, okay, and AF is a vehicle frontal area. So how much pressure is creating in front of the area, we can be find out with the help of we can how to indicate, and V is a vehicle speed, okay, you can see, and the CD is a drag coefficient, how much the vehicle is dragging. So that is called as a drag coefficient. Anybody knows that what is the maximum drag coefficient should be there for a passenger car? It should not exceed that. So you can see the aerodynamic drag coefficient of frontal area of different vehicle types I have shown over here. Okay, motorcycle with a rider vehicle. This is a it indicates vehicle type. So uh, this is a vehicle type. Motorcycle with rider, and CD is a drag coefficient. Area frontal area. AF is frontal area. So when the frontal area is between zero point 0.7 to zero point 0.9, okay, AF is in square meter, okay, it has been indicated, and doesn't have any unit, okay. So zero point 0.7 to zero point 0.9, okay, so drag coefficient should be between 0.5 to zero point 0.7 for motorcycle with rider. So open convertible, for open convertible we have a AF that is 1.7 to 2.0. So that is the CD is 0.5 to zero point 0.7. Again, if you consider both the things are same. So for limousine and all, so 0.1, 1.7 to 2.3. Uh, so drag coefficient is of 0.22 to 0.4. So for coach, so you can see these are the values of drag coefficient. So you can see, if you can refer this second column CD drag coefficient, anywhere is not crossing above 1. Okay, only for the truck with a trailer is having 0.55 to 1 point 0 of drag coefficient. Other than that, you can see for the different vehicle type, it is only up to 0.9 only. So that drag coefficient should not cross at around 1.1 or 1.2. Okay, so the people are going to reduce the drag coefficient, okay, with the help of there are different tests are there, aerodynamic tests are there. So tunnel test will be done, मतलब एक टनल बनाया जाता है शायद वीआईटी में है, ड्रैग एरोडायनामिक टेस्ट करने के लिए वीआईटी में टनल वगैरह क्रिएट किया हुआ है. So vehicle will be going in that particular tunnel, that is like a demo model, and air will be flown in front of the vehicle. According to that, what is drag is just generated on the vehicle and how it has been reduced. So more and more drag, if it is it is producing on the vehicle, then it also affects the performance of the vehicle. Okay, that is the main thing. So grading resistance. So grading resistance can be vehicle goes, मतलब grading resistance is gradability, we call it as when a vehicle goes up or down. तो up तो जाएगा और down तो जाएगा. तो goes up and down slope. It weight produces a component of front that is always directed downwards. Weight मतलब अगर front भी जा रहा है तो आपका weight downward direction में ही डायरेक्ट होगा, और आपका व्हीकल डाउनवर्ड डायरेक्शन में भी जाएगा तो आपका व्हीकल वेट और फोर्स कैन बी acting in the vehicle weight is acting in the downward direction only. Okay, that is indicated over here in this figure. Okay, that can be written, this force component opposes the forward motion. Okay, again I have explained many a time, that is grade climbing. When the vehicle goes down the grade, this force component aids the vehicle motion as well as the gradability resistance. Okay, FG is called as a gradability resistance. Okay, so this is acting in the force is acting in the downward direction, can be written as mg sine alpha, where m is a mass of the vehicle, g is the acceleration, constant, and alpha is a angle. So acceleration resistance, this is also same thing. Acceleration resistance, the total mass of the vehicle and the inertial mass of those rotating parts of the drive accelerated or braked, okay, uh, are the function of influencing resistance to the acceleration. Okay, so this can be written as F is equal to delta m dv by dt. That can be written acceleration resistance. So here delta is nothing but rotational inertia constant, and m is the mass of the vehicle, v is the speed of the vehicle. Okay, so that also be considered. Acceleration resistance also can be considered. Over here, what happens? The rotational component is a function of the gear ratio. So as I said, like delta, and the moment of inertia rotating drive the element of the engine. So the like clutches, gears, drive shaft, etc., including all road wheels, are reduced to the driving axle. Okay, whatever the driving axle is there, that reduced to the driving axle. And this is an acceleration resistance. Okay, we call it as Fa is called as a acceleration resistance, and the delta is called as a rotational inertia constant, and m is the mass of the vehicle, and v is the speed of the vehicle. So total driving resistance can be indicated with the help of this. Okay, total driving resistance. So total driving resistance, matlab the traction force required at the drive wheel is made up of driving resistance force, and forces are defined as like Fr, Fw, Fg. As I explained, all the parameters like aerodynamic resistance, rolling resistance. Then we can call it as Fa. Okay, this is aerodynamic drag, Fw. Then grading resistance. These all will be written as, so though all can be written over here. F resistance is equal to mgr cos alpha for fr rolling resistance. Okay, then aerodynamics resistance gradability. Okay, and fa, so that is fa is called as grading resistance, fg is called as a grading resistance. Okay, fa is called as a acceleration resistance. So acceleration resistance can be written over here, delta lambda m, sorry, lambda m dv by dt, and fa is a, over here, mg sine alpha, already we have seen over here. So fg is a mg sine alpha, and this is aerodynamic force. So that is half rho af cd v square, and this is a rolling resistance. Okay, also rolling resistance which helps एक्सेलरेटिंग व्हीकल टू डिसेलरेट. रोलिंग रेजिस्टेंस ये भी हेल्प करता है कि जो भी एक्सेलरेट हो रहा है व्हीकल उसको डिसेलरेट करने में भी हेल्प करता है रोलिंग रेजिस्टेंस. So that's why it make a more impact on the engine of the vehicle or drivetrain of the any kind of vehicle. Okay, so these are the different parameters are there, so which will be effect on the performance of the vehicle. So we are going to write down the dynamic equations. So as I said, so we are going to write down the dynamic equation for wf and wr. Okay, by tomorrow we are going to derive an equations for this. Okay, so and how you are going to get for the front tire, and what are the reaction forces we are going to get for the rear tire, and how we can replace with the help of different terms or in the equations. Okay, so I'll stop over here today. So we'll continue tomorrow. Okay, these are required. The knowledge of these things are required. Okay, so whenever you have the whatever the performance of the vehicle, so these are the main things we need to study. If any kind of vehicle is there, whether it is a conventional vehicle or whether it is any kind of vehicle, so we are going to see. Okay, so today we will stop again. Tomorrow we will meet at the same time. Okay. If you have any queries, then you can ask me. Otherwise, put your roll numbers in the chat box.
Hello. Sir, when we supposed to take coefficient of lift into consideration in aerodynamics?
Which one?
When we supposed to take coefficient of lift into consideration in aerodynamics?
Uh, when it is going uphill, when it is going to uphill, so you have to take the lift of the vehicle, aerodynamic lift of the vehicle, because it is moving in upward direction, no?
Okay. Okay. Okay.